Why, one might wonder, does understanding statistics matter? In a world increasingly driven by data, numbers, and figures, the ability to interpret and understand statistics has become not just a skill, but a necessity. But how does one go about analyzing statistics? Three main methods exist: understanding the methodology, seeing self-relevance, and recognizing uncertainty. First, consider the methodology used to collect the data. Each statistic is a product of a certain process, a method. It's crucial to understand this process, to know how the data was gathered, and what measures were taken to ensure its accuracy. Did the process involve a random sample of a population, or did it target a specific group? Was the data collected through surveys, experiments, or observations? Understanding the methodology gives you a clearer picture of what the statistics represent and how reliable they are. Next, look for self-relevance in the statistics. By self-relevance, we mean the degree to which the statistics apply to your own situation or context. This involves asking questions like, how does this statistic relate to me? Or, how does it affect my community, my business, or my research? Seeing self-relevance in the statistics not only makes them more interesting and engaging, but also helps you to apply them in a meaningful way. Finally, recognize the uncertainty. Statistics are rarely absolute. They usually come with a degree of uncertainty, often expressed as a margin of error or confidence interval. This uncertainty arises from various factors, such as the sample size, the variability in the population, and the methodology used. Recognizing the uncertainty helps you to understand the limitations of the statistics and to interpret them with an appropriate level of caution. To summarize, analyzing statistics involves understanding the methodology, seeing self-relevance, and recognizing uncertainty. By understanding how the data was collected, you gain insight into what the statistics represent and their reliability. Seeing self-relevance helps you to apply the statistics in a meaningful way, while recognizing uncertainty allows you to interpret the statistics with an appropriate level of caution. Armed with these three tools, you're well on your way to becoming a savvy statistician, capable of navigating the complex world of numbers and figures with confidence and ease. Having armed ourselves with the knowledge of how to analyze statistics, it's time we dive into the realm of spotting bad statistics and identifying the reliable ones. Some common signs of bad statistics are lack of context, misleading graphs, and unrepresentative samples. For example, if a statistic claims that 80% of people prefer a certain product but doesn't mention the demographic or the sample size, it's likely a bad statistic. On the other hand, reliable and accurate statistics are those that provide clear context, are based on representative samples, and present data without distortion. For instance, a study showing that 70% of a randomly selected group of 1,000 adults prefer electric cars over gasoline ones, with a margin of error of 3%, is a good statistic. Always remember to scrutinize the methodology, self-relevance, and the uncertainty of the data. By keeping these points in mind, you'll transform into a discerning consumer of statistics, capable of spotting bad statistics and identifying reliable and accurate ones.